Hi there, this is section 31 and with a video on how to set up a WireGuard VPN tunnel using OPNSense. In this video, I'll quickly go over what a VPN tunnel is, what WireGuard is, and why you might want to set up a site-to-site tunnel of your own. Then, I'll dive right into a tutorial on setting up a basic site-to-site VPN tunnel configuration. What is a VPN tunnel? A VPN tunnel, known as a virtual private network tunnel, is a way of creating an encrypted link between two different networks. All traffic that flows to this tunnel is encrypted from point A to B and point B to A. This is useful when you have two networks in geographically distant locations where you want to be able to access the services and devices of each network. What is WireGuard? WireGuard is a lightweight, free, and open source communication protocol and software that allows users to easily create a VPN that has high speed performance and state-of-the-art security. Compared to IPsec or OpenVPN, in tests that I and others have performed, WireGuard is significantly faster. Not only that, but WireGuard uses state-of-the-art ciphers and doesn't really have that issue of supporting older and insecure protocols for backwards compatibility that the other existing solutions have. Therefore, that lowers the potential attack surface. So, why would you want to use a VPN tunnel? Well, the most common reason to use a VPN tunnel is to access resources such as services, servers, and computers on two different remote networks. So for example, I use my VPN tunnel to transfer files between my two NAS. They sync between each other over this encrypted tunnel. Another thing that I do as well is set up private websites that can be accessed from both locations and are inaccessible to the outside public internet. And the final thing that I use it for is to make configuration changes to devices on the remote end. Here is a network diagram for our two LANs. On the left we have site A and on the right we have site B. They'll be connected to each other over the WireGuard tunnels. On the left you can see we're going to have the tunnel address 192.168.254.1 and on the right we're going to have the tunnel address of 172.16.254.1. The WAN address is 10.031.113 for site A and 10.031.123 for site B. To begin configuring our WireGuard VPN tunnel, we'll go ahead and log in to Firewall A, which is OPNSense A here. We'll go ahead and click on the VPN link here and then go to WireGuard. You'll notice by default that the WireGuard service will be disabled by default. Go ahead and click on the local tab and we'll go ahead and add a new local interface. We'll give this the name Tunnel A, leaving both public and private key empty as these will populate once we click save. The default port for listening is 51820, which we're going to go ahead and use here. The tunnel address should be an unused IP address. It could be a range or it could be a single IP address displayed in CIDR notation. We don't need more than one address, so we're going to go with a /32 here. We are using 192.168.1.1 here for the gateway and the firewall IP address. So we're going to go ahead and pick something within the same subnet. We'll go 254.1/32. There will be nothing to select in the peer as we have not created that yet, and we don't want to disable routing. Go ahead and click Save. As you can see, a new local configuration has been created. Go ahead and click Edit, and you can see now that the public and private key have been generated. Do not share the private key with anyone. This should remain secure with this firewall. Otherwise, people can get into your tunnel. Go ahead and copy out the public key for future use. Now that we've created the local configuration for Firewall A, we'll do the same thing on Firewall B. Click on VPN and WireGuard. Going into the local tab, we'll add a new local configuration. For this one, we'll give the name Tunnel B. Public and private key will remain blank. 51820 for the port. And here we're going to give the tunnel address of 172.16.254.1/32 and click Save. Once again, grab the public key here and copy that to a safe location for the next step. Now clicking on the Endpoint tab will create the connection from tunnel B to tunnel A. In order to make this easier to understand, I'll name this tunnel to A, and we will paste the public key for OPNSense A into the public key field here. If you wish, you can use a shared secret to enhance the security, but it's not necessary for the security of your tunnel to necessarily need this. But if you want to future-proof it, you can. But this public and private key pair encryption is pretty secure already on its own. For the allowed IP addresses, we need to specify the IP address ranges that are available on coming from tunnel A. So if we recall, we need to specify the tunnel address that we configured on the local side of tunnel A. And if that's the only thing we needed to connect, then that would be it. But we also want to allow the local LAN over on tunnel A as well. And so we will pass in 192.168.1.0/24, giving all those addresses access here. The endpoint address will be the WAN interface IP address for tunnel A. Alternatively, you can also use a domain name here, and you can pair that with dynamic DNS in order to have an updated IP address at all times. In our example here, we'll go ahead and use the WAN address that we have here. Now note that this is a lab environment, so my WAN IP addresses are RFC 1918 internally routable addresses and not public IP addresses. But that's okay, this will still function. 51820 is the endpoint port. I like to also set a keep alive. If there is no traffic going across the tunnel, then the tunnel collapses. The keep alive allows that to stay open and will run every 60 seconds. So go ahead and click Save. And we'll go now to the local tab again. Click Edit. And select the tunnel to A peer. Go ahead and save, apply, go to the General tab, click Enable Wireguard, and then click Apply. Now that we've completed this, we can validate our configuration by clicking on this configuration. As you can see, the interface has been generated and we have a public key. If it was connected properly, then we would see a peer here as well. You can go to the Handshake tab, and once we have established a handshake, we will get the interface plus the public plus the epoch time of the handshake in this tab. While we're on OPNSense B, Firewall B, there's a few other configurations we need to make as well. The first thing we want to do is go into Interfaces and click on Assignments. You note here that there's a new interface, WG0, which is a virtual interface that has been created for our WireGuard tunnel. So we're going to go ahead and add that, and we'll name that WireGuard tunnel. This is useful because we can configure specific firewall rules to this interface, giving us further customization options. Now that we've created the interface, click on the WireGuard tunnel interface. Enable the interface. I like to also prevent the interface removal. This prevents you from disabling the interface. Do not select block private networks, as we are passing private networks across this tunnel, so we don't want to block those addresses. You can, however, select block bogon networks. These are typically IP addresses that haven't been assigned, they're reserved, and shouldn't be passing through your tunnel. All the other fields can remain in their defaults. Let's click Save and Apply. We now have an active interface. The final step before we go over to Firewall A is to configure rules for the Wireguard tunnel interface. Now, depending on your security posture, you may want to limit what ports are allowed across the interface. For our example, we're going to go ahead and create all allow rule. So you can leave the defaults, everything is any. But in this case, I'm going to click log packets and fill in a description. Normally for allowed traffic, you will not want to log the packets, as this generates a lot of data, but it's useful to enable temporarily for troubleshooting purposes. Go ahead and click Save and Apply. Now, if we go to the lobby and the dashboard, one of the things that is valuable to validate is that the WireGuard tunnel has received its interface address. And for some reason, it has not. And when it doesn't receive an interface address, then it appears to not allow traffic through properly. So one way of validating this is to go back into WireGuard, disable WireGuard, and then re-enable. This is assuming that we've configured the tunnel address properly. And it should get this address, 172.16.254.1. As we can see here now, the interface has received that address. That completes the configuration for Firewall B. So now we'll go back to Firewall A and finish the configuration there. Back on Firewall A, go ahead and click on the Endpoint tab and add a new endpoint. For the name, go ahead and use tunnel to B. And we'll paste the public key now from Firewall B's tunnel B local tab here. The shared secret is optional, but we can use that if we want additional security. We didn't use that previously, so we'll skip that. For the allowed IP address, we'll be using the tunnel address and the main subnet for Firewall B. The tunnel address is 172.16.254.1/32, and the LAN address is 172.16.0.0/24. The endpoint address will be the WAN port for Firewall B, and that's going to be 10.0.31.123. The endpoint port is configured at 51820, so we'll go ahead and put that in this field again. And the keep alive, I'm using 60 seconds. Go ahead and save and click on the local tab. Edit. We're going to go ahead and add the peer here. Save. And then apply. Go ahead and enable the WireGuard service and click apply. We can check that it's working by going to this configuration tab. Now we'll go into interfaces, assignments, and add the WG0 interface, giving the description WireGuard tunnel. Click add and save. Go back into the WireGuard tunnel interface, enable interface, prevent the interface removal, and select block bogon networks. Save and apply changes. Back on the dashboard, we can see that the WireGuard tunnel interface does not have an IP address. Now, one of the things we can do is actually just reset the WireGuard service from the services widget here on the dashboard by clicking the little arrow icon. This will be much quicker to get that interface going. As we can see, the WireGuard tunnel now has 192.168.254.1. We'll go ahead and make the firewall rule changes now. Once again, we're going to give a very permissive rule. So go ahead and go into Rules, WireGuard Tunnel. Real quick, I want to show some automatically generated rules. These are 2 rules that are created when we checkmark the disallow bogons. Go ahead and click Add now. We'll create the new pass rule. Leave everything on the default for pass. The interface is WireGuard Tunnel, and then we're going to set the logging enabled and then give it a description for troubleshooting purposes. Once again, you probably won't do this in a production environment as the logs generated for allowed rules can be excessive. If you have the disk space for it, then go for it, or a remote logging server. Now that we've completed the configuration changes, we can check that everything is working properly. Going into the VPN and WireGuard section, we can click on List Configuration, which will show the currently running configuration. Over here in the top, we have the interface WG0 along with the public key. If we have established a connection properly, we will see appear here with its public key, its WAN address, as well as the allowed IP addresses across, and a bytes transferred section. If everything is working, clicking on the handshake tab will show the epoch time of the last handshake. If it is 0, we're not receiving any handshakes. The other way to view this is clicking on the lobby dashboard. And if you haven't added the widget, you can add this WireGuard widget, which will show the interface, endpoint, and the timestamp of the latest handshake. This is valuable for keeping track of your tunnel activity. Now, the final thing to try is to validate whether we can reach the LAN address for OPNSense Firewall B. Go ahead and open up a new tab. And we'll browse to 172.0.1. And we have a login screen here, which is a good sign. Let's see what happens when we log in. Well, as you can see, we are now on OPNSense B and OPNSense A. Our tunnel has been completed, and we have access to both LANs now across the WireGuard VPN tunnel. That's all for this tutorial. If you want to do more complex configurations and would like guides for that, let me know in the comments. If you want to see more videos like this and focus on security or OPNSense, also let me know in the comments. Hey, it's Section 31 again. Thank you for watching this video. If you like this video and you want to see more, please like and subscribe. If you have questions or if you have ideas for future videos you want to see, go ahead and leave me a comment down below. This is Section 31, signing out.